All right, everything that we've covered so far are autosomal traits. Those are found on the autosomal chromosomes, those 22 normal, quote-unquote, chromosomes. But we do have sex-linked chromosomes. So sex-linked chromosomes, so that 23rd pair, are going to have traits as well encoded in the chromosome. So we can have the same idea where we figure out the probability of offspring inheriting parental traits. So genes that are carried on the X chromosome are said to be sex-linked. Color blindness, which you guys are going to figure out if you have today, is a sex-linked trait. Color blindness is a recessive trait. It's a sex-linked recessive trait. So you can't have a dominant trait that's going to mask that recessive trait. Okay, using these symbols down here, you guys are going to list the 5 possible genotypes and their corresponding phenotypes. So I want to help you with this since this is the first time you're working with sex-linked traits. I'm going to go ahead and list my homozygous dominant at the very first, like I'm used to doing. So I'm working with the female here. Female is 2 X chromosomes, and my dominant, I'll go ahead and write the uppercase A's as best as I can. Those are uppercase A's. So this individual is normal. So for my next genotype, 2 X chromosomes, that doesn't change. I'm going to have an uppercase A and a lowercase a to show you my heterozygote that is normal. My last female will be 2 X chromosomes, 2 lowercase, that is a homozygous recessive. That individual is diseased. That individual will be color blind. Okay, my male, I can actually only have 2. So for that reason, you're actually going to X out that bottom row here for the male. You just won't have to write anything there. Let's go ahead and write our 2 different genotypes for the male. Remember, male is XY. So I'm going to write XY for those 2 sex chromosomes. The X can either be A, uppercase, so I'll go ahead and start with that. The Y, notice that the Y, I'm not writing anything. I only got one option for the Y. There is no allele on the Y, and that's true. The Y does not carry that trait. So I just leave the Y blank. This individual, there's only the dominant allele for this male, so then this individual is said to be normal. Next male, XY, I only have another allele that's different, that lowercase a. For this male, unfortunately, that lowercase a does not get masked by anything on the Y chromosome. That Y chromosome just doesn't have another trait, so then this individual is said to be diseased. If you think about it, the male has a much higher chance to be diseased because the Y chromosome doesn't mask that X chromosome that the male has, unlike in the female, where you have less of a chance of being diseased since you carry 2 X chromosomes. I'll let you guys think about it and answer those questions yourself.